Hey, today we are going to talk about an actual formula to help us find slope. We've been using graphs and doing the rise compared to the run, but sometimes we're not always going to have a graph. So we are on pages 5 and 6 in our notes, so go ahead and get that out. And you also need your calculator most likely because we'll be doing some calculations. All right, so just kind of a little bit of a review from when we've been doing slope. We have this first little problem. It says to find the slope of the graph, Aiden counted the rise to be 6 and the run to be 8. So he counted, he saw that the scale was 2, so he went up, or he went this way for 6 for 3 boxes, and this way for 8. Okay, so he wrote his ratio as 6/8, and that can be simplified to 3/4. So it's asking, instead of using the graph, instead of just using the ordered pairs, we have 8, 10, and we have 16, 16. How else could we use these ordered pairs to find the rise to be 6? So what we're going to look at when we think of rising, we think of going up or going down. Okay, so when you think about, okay, well, looks like our y values are what moves us up and down on an ordered pair. So when we talk about how to go from 10 to 16, the difference between them would be 6. Okay. Then we also have, how could we use our ordered pairs to find the run being 8? Can you let him out? So we look at our run being our left and right direction, which would be our x coordinates. So how we can go from 8 to 16 would be 8, or 16 minus 8, the difference in them being 8. So we've kind of done this before, we just haven't actually seen ordered pairs. Okay, so the slope formula, we can describe slope as the following: the rise and the run. We also talk about it as the change in our y values over the change in our x values. And this is actually what I use more often than not, even more than this formula I'm about to show you. But another way we find change is by subtracting. So there is a formula, and the formula would be your y2 minus, because I would find the change, your y1 over x2 minus x1. So this is a formula. It works 100% of the time. And I'll show you guys how to use that, but I'll also show you guys how to use the change over the change as well. And it's your personal preference. If you feel like you have good number sense, the change formula might be better than the actual slope formula. If you want a way that works 100% of the time, the slope formula always will work. Okay. So let's go ahead and let's try one with the formula that we just talked about, the change, so the subtraction problem. And then there's another way that we could do it as well. All right. So we have this table. It has 4 ordered pairs, basically. Okay. It has x coordinates and it has y coordinates. So the first thing, if we're trying to find the slope or the rate of change, we have to pick 2 of them. Okay. So you get to pick any of these 2. Okay, I'm going to pick easy ones. So to me personally, I like ones with no decimals. So I'm going to pick 0, 5 and 2, 6. Now, if you would have picked 1, 5.5, you would still get the same answer. Okay, so here are my x coordinates. This is my first x coordinate. So we're going to label this as x1 with a little subscript of 1. Okay, then this is my y coordinate. And so we will label that as y1. So this is the first point. This is the x coordinate, and this is the y coordinate. Okay. Then this is the second ordered pair that we're going to look at. 2 is the x coordinate, because I'm just matching that. And 6 is my y coordinate. So I'm just labeling that as y2. So the first thing we have to do is we just have to label, make sure we understand what is our x1, y1, x2, y2. Okay. Then I like to write the base of the formula. So the base of the formula is basically a fraction because we're finding the rise to the run. So we have a ratio, okay? And what we need to do right now is we need to find the difference between them. So we are subtracting, okay? So that's what I always start with this problem. All right, now we are going to now just plug this into our formula. So the formula says y2, so y2 is 6. Minus, we already have the minus sign. y1, my y1 is 5. So I'm just substituting in the values from the table. All right, then on the denominator, we have our x2, which is 2, minus, so I already have the subtraction, that's the base of the formula, and then x1, which is 0. All right, after we do that, we just have some math problems to do. We do 6 minus 5, which is 1, and then we have 2 minus 0, which is 2. So I can't simplify this, so the slope is 1 over 2. It's going up 1 for every time I'm going over 2. All right. Now, there is another way of doing this instead of using the slope formula. So I'm going to show you guys the other way. And this would be, instead of using the slope formula, this would just be basically finding the change and finding the change. Okay. So again, you just have to pick 2 points. This is a table that has 4 ordered pairs, and you just have to pick 2 of them. I like to look for easy ones. Since there aren't any decimals or fractions, I'll just use the first 2. Okay. So here are my y values, and I'm just going to first ask myself, how do I change from 22 to 62? How do I go from 22 to 62? And it looks like it's going up 40. Okay, so the change in my y values is going up 40. So I'll show that with a positive. All right. Then I ask myself, how are the x's changing? This is going from 3 to 8, excuse me. So I just said the answer. How do you go from 3 to 8? You add 5. So the change in the x values is up 5. So again, a positive number. Then we can just simplify this fraction. 40 ABC 5 would be 8. So the slope of this is 8. Okay. Now, again, you have to kind of have some good number sense to know how do you go from 22 to 62. But what you're really doing is when I say, how do you go from this to this, you're basically just finding the difference between them. So you could just do 62 minus 22, because that's what the formula would do, minus 8 over 8 minus 3. So that would get you the same exact answer. So you just have to pick which one you like. We'll do a couple more both ways, and then you can kind of pick your preference. All right. For number 3, we have a graph. So we could do just rise over run, okay? Or it does give us ordered pairs, so you could also do it a different way, okay? I'm going to show you guys a third way if you like this way. All right, so we just have to write down these ordered pairs. So the first ordered pair is right here, and as an ordered pair, that would be 0, 80. Okay. For the second ordered pair, that would be 5, 50. Okay. So this is very similar to the change over the change. So I'm going to find the change in my y values compared to the change in my x values. Okay, so just a little heads up, you know, your ordered pairs go your x coordinates and your y coordinates. So first, how do we go from 80 to 50? And it looks like we're going down, so we'll show a negative 30. So to go from 80 to 50, we would have to subtract 30. Okay. Then we have to find the change in our x values. How do we go from 0 to 5? We go up 5. Okay. Then if we simplify that, we should get negative 6. So our slope or our rate of change is negative 6, or negative 6 over 1. Okay. If you like the formula way, a way that works 100% of the time, okay, you would just have to plug in the value. So the formula is y2 minus y1. Our y2 is our second y coordinate, so 50, okay, minus y1, which would be 80. Okay. Over x2 minus x1, our second x is 5, our first x is 0. Okay. So 50 minus 80 is negative 30. So again, we're getting the same value. And 5 minus 0 is 5. So again, we're getting the same value. Do you like it's up to you if you like to find just the change in the numbers, or if you like a formula that works 100% of the time. Okay. So now we're going to go to page 6. Now we are going to have just ordered pairs. So for these ones, we had a bunch of ordered pairs that we could pick from. These ones, we just have 2 of them. All right, so again, I'm going to show you guys with the formula way and then with kind of just the change way, and you guys can pick whichever you prefer. Okay, so first, if I'm going to do the formula, I like to label first. So this is my first ordered pair. This is the x-coordinate of my first ordered pair, so I put a little x1. Here's the y-coordinate, so I put a little 1. Here's the second ordered pair, so I'm writing x2, y2. Then if I'm using the formula, I'm just writing the base of the formula. It is a subtraction problem. Okay, again, I'll just write the formula right here so we can reference it. Okay. All right, so if we like the formula way, that is awesome. Okay, we're going to do y2, so 7 minus our y1, 4, over our x2, 1, minus our x1, 2. So again, if you like the formula, it works 100% of the way. You just have to just plug it in, basically. 7 minus 4 is 3. 1 minus 2 is negative 1. So the slope would be 3 over negative 1. You could also simplify that to negative 3. All right, I'm going to show you guys with the formula way one more way, just so you guys feel comfortable with this. So the first thing is we label. So this is our first ordered pair, our x-coordinate, our y-coordinate. This is our second ordered pair, our x-coordinate, our y-coordinate. And then I like to write the base of the formula. Okay. Now again, all I'm doing is just substituting in the values. So y2 is negative 2. My y1 is negative 1. So I'm still writing negative 1 right there. Okay. My x2 is 3. And my, whoopsie. Oh, sorry. Okay. So, sorry, y2 was negative 2. Our y1 was 0. Okay. Our x2 was 3. And our x1 was negative 1. So again, I'm just writing negative 1. All right, now we need to do some calculations. Negative 2 minus 0 is negative 2. And then 3 minus negative 1. Again, you can just type that into your calculator, okay? Or you could also know that subtracting a negative is like adding. So that would become a positive 4. My dogs are playing right now. They're playing. All right, so now we can simplify negative 2 over 4 to have a slope of negative 1 over 2. That is an equivalent rate. So the slope of this line would be going down 1 over 2. So again, if you like the formula way, I like the formula way, it works all the time. Okay? Now, if you like another way, there is always another way. All right, I'm going to find the difference between my y values over the difference or the change in my x values. Okay, so again, I just have to know that this is my x and this is my y, this is my x and this is my y. Okay, so you just have to make sure you're consistent. Okay, so I'm going to go from here to here. How do I go from 3 to 5? Well, I add 2. Okay, so I'll show positive 2. Okay. Then if I go from 3 to 5, I have to go from 1 to 5. So how do you go from 1 to 5? You add 4. So the slope would be up 2 over 4, or simplified, it would be 1 over 2. Okay. All right, so we'll do number 7, just a little different. It's very similar to this way, but some of us like a different way. So if you like another way, if you like the table way, I prefer the table way. So this would be to create a table from your ordered pairs. Okay, so x, y. So for this one, the x-coordinate is 4.25. The y-coordinate is 0, so that's an ordered pair. For this one, you get 3.5 as your x-coordinate and 3 as your y-coordinate. Right? So then if we like this way, we would just do the change in our y's. So how do we go from 0 to 3? We add 3. Okay. And then how do we go from 4.2 to 3.5? Okay, well, we're going to have to go down. Okay, and basically if we don't know what that is, and that's fine, okay, we have to find the difference, so we need to subtract. So we know we have to go down. So we could do 3.5 minus 4.25 and get negative 0.75. So you can still use your calculator to do these calculations. We need to find what the difference between them is. So the change in my y's is a positive 3 because I went up to 3. This one, I went down 0.75. Okay. Now, when we type this into our calculator and we type in 3ABC negative 0.75, we'll get probably an error. And that's because when we're using the ABC button, it's assuming it's a fraction. But when we're using a fraction button, we can't type in a decimal. Okay, so if the ABC button doesn't work, okay, again, fractions are the same thing as division. Let's try dividing. Okay, because we do have our calculator that will convert it back into a fraction for us. So we're going to hit 3 divided by negative 0.75. So instead of the ABC button, using division, and we get negative 4. Okay. So we already know that that's a whole number, so we could put it over 1 if we want to, but we don't have to. We could just say that it's negative 4. Then if it was still a decimal, if we hit the second PRB button, then we convert it back to a fraction for us. All right, so I'm gonna do the change way, one more way, just like 6, and then for number 9, we'll do the ordered pair way. So just so you guys can get kind of a couple examples of each way, which one you like the best. All right, so if you like the change in the y over the change in the x, okay, here is my y values. To go from 3/4 to 3/4, I wouldn't add anything. It would be the same exact number. Okay. Then to go from 2 to 5, we're adding 3. Okay. Again, if you don't feel confident with just like using our number sense, that's totally fine. We're going from 2 to 5, so we could just subtract 5 minus 2 and get 3. You could also do 3/4 minus 3/4 to get that 0. Okay, so the change in the y values was nothing, and the change in the x values was 0. Okay, and if we type in 0 divided by 3, we get 0. So the slope is 0. Remember that 0 is a flat line. All right, for number 9, we'll just do it the table way just to have another example of that. Okay, so for this first ordered pair, the input is 7.5. The y value is 3. For the second one, we have 7.5 and 2. Okay, so then we just find the difference between them. To go from 3 to 2, we go down 1. Okay. Then to go from 7.5 to 7.5, we stay right there. So we're just not going anywhere. So the change in my y's over the change in my x's would be, my change in my y would be down 1. The change in my x's would be nothing. Okay, and then if we type that into our calculator, we get a syntax error. And that is because we cannot divide by 0. That does not exist. So the slope of this line would be undefined. All right, we're going to do 2 more. This is rate of change, so some word problems to it. So again, you can pick the formula way, you can pick the change way. These are tables, so I will most likely do it this way because it's already kind of set up that way. The table shows the relationship between the number of songs Alicia has purchased and the cost of her purchase. Find the rate of change or the slope. So we have number of songs, so 2 songs cost her $3.27, 5 songs cost her $6.24. Okay, so all of these are decimals, so I'm just going to pick the first 2. Okay, you could pick any 2 that you want, but I'm just going to pick the first 2. Okay, so I'm going to first find the change in the y values or the cost in the purchase. So I need to find the difference between this money. Okay, and I'm going to use my calculator. Okay, I'm just going to subtract 624 minus 327, and I get $2.97. Okay, so that's the change in my y values. Okay, then I'm going to find the change in those number of songs. So how do we go from 2 songs to 5 songs? Well, 5 minus 2 is 3, so 3 songs. So the rate of change is $2.97 for every 3 songs. Okay? And with word problems, usually we don't like to talk about 3 songs. Usually the unit rate or 1 song would be the most would make the most sense. So now we can take 297 and we can actually divide it by 3 and we get 99 cents. Okay? And so that is equivalent to 99 cents per song. Okay? And because this is a word problem, unit rates do make sense, and so we would not have to convert this into a fraction if we did not need to. Okay, because 99 cents is a real application. We understand what 99 cents means. Okay, For number 11, it says the table shows the distance that Andy and his friends have left on their road trip based on the number of hours they have driven. Find the rate of change or the slope. Okay, so we have hours driven and miles remaining. So X is the hours driven, Y is the miles remaining. So we're just going to find the rate of change or the slope. We could use the slope formula, but if it's already set up, we're just going to find the difference. So we can ask ourselves, how do we go from 360 miles to 240 miles? So I'm just going to subtract 240 minus 360, and I get negative 120. So negative 120 miles. And then I ask myself, how do I go from 1 hour to 3 hours, which would be 2 hours? So the rate of change would be negative 120 miles for every 2 hours. So that is the rate of change. Usually, again, with word problems, we like unit rates. So we are going to take negative 120 and divide by 2. So the rate of change would be negative 60 miles per 1 hour. So they're getting closer to their destination by 60 miles every hour. Right. For this last problem, it says the post office charges a flat rate plus a cost for shipping based off the weight of an item. Okay, so to ship a 2-pound item, it will cost $6.09. To ship a 7-pound item, it will cost $8.84. So as I read that, I just wrote down this information. This would be pounds of the item, and this would be the cost of the item. Find the rate of change or the slope of this situation. So I'm just going to find the difference in the money. Okay, so how do I go from $6.09 to $8.84? So I'm going to do $8.84 minus $6.09, and I get $2.75. Then I'm going to find the change in the pounds. We go from 2 to 7 pounds by adding 5 pounds. So the rate of change would be the change in our Y values, so $2.75 for every 5 pounds at the post office. Again, we want a unit rate because not everybody buys in increments of 5 pounds. So if we take $2.75 and divide by 5, we get 55 cents per 1 pound. So that would be the unit rate or the rate of change. All right, then we're going to have a Delta Math assignment.